And take another sip of tea. Morning, John. So I'm going to leave the chat open for a moment. Our first order of business is to look at when our final is. I just want to remind you, so we are a Monday, Wednesday class that starts at 9 a.m. So our final is on Wednesday, 12/16. So just double checking. Our class starts at 9 a.m. Monday, Wednesday class. So the final is from 9 a.m. right here to 11 a.m. on 9 to 11 on Wednesday, 12/16. So let me put that in the chat. Let me go back up to y'all and put this in the chat. So our comprehensive final is on Wednesday, 12/16 from 9 a.m. to 11 a.m. I would allow 2 hours for the final. It will be the same length as all of your tests have been. So I'm not going to increase the length of the final. So just to give you an idea, it will have written work required questions. I can't tell you what they are. It would violate departmental policy. I wish I could tell you what they are, but I can't. I'm not going to violate that. And so it's just going to be just like that. 7 written work required questions, and then the last 10 will be answers only. And that's because I have to review all the proctored sessions for all 6 of my classes in addition to grade the written work. So I've got a lot of work to do. Speaking of your tests, test 3s, I'm sorry, I've just had things come up this week, including wanting to get all of my final exam reviews out to all of my students, which I have already done. So I have gotten that checked off my list. So now I can grade. And I am ready to go for my last 2 remote classes tomorrow. So I'm good. So I will work on grading them today. So I will definitely send you all an email when those tests have been graded. And I'm sorry for the delay. It's just so many things are coming up. Students are asking me to write references, and I don't want to say no. And, I'm trying to take care of all my students at the same time. So I think I'm good to go, though, for today, and I will sit down and work on them. So let's get started. We have one more section to cover in the course. Remember that final exam review assignment is ever so important that you go through and do that assignment for a few reasons. Number one, it's worth up to 5% bonus. 5% bonus is a lot in a course. So just to give you an idea of approximately how many points that is, that's 30 points. 30 points can make the difference between passing a final and failing a final. So let's say you got a 70% on the final. 30 points could put you up at 100. So that gives you some cushion there, so you can still pass the final. So in addition, you're likely to do better on the final because you did that assignment. I can tell you every question, every problem type that you will see on the comprehensive final is in that final exam review. So that's reason, I think, enough to actually go through and do that assignment. It does have a lot of questions in it. It can't be done in one evening, I would say, unless you're really a whiz at survey of calculus. Let's take a quick look at that assignment now, just to see how many questions there are. So if you go to homework, scroll down, and I need to assign the partial derivative homework that we're going to do today, and I will do that right after class. So 12:15, the departmental review is due. It's unavailable after stated due date. So it's due the night before your final, and your final's at 9 to 11 a.m. So I want to encourage you to get some rest there. And if I click on that assignment, you can see there's 82 questions on that assignment. So there's a lot there. So I just want to encourage you, that isn't something you really could do in one night. I did not write out the solutions for this assignment. It has these many, if not all of these questions you have seen with small changes throughout the semester, so I did not write up those solutions. I wanted you to really prepare for the final. Any questions so far before we get started on today's section, which is on partial derivatives? So the reason why we are looking at this partial derivatives assignment is to give you some sense of working in 3 dimensions. What is it like to do calculus problems in 3 dimensions? In other words, if you notice here, we are taking these partial derivatives. So let me just explain the notation. This right here means the partial derivative of z with respect to x. So what's varying is this z. So you've got, in this case, when we're talking about 3 dimensions, we have 2 independent variables, x and y, and 1 dependent variable, z. That depends on whatever x and y are. So we are really working in 3 dimensions. So this one down here, so this really means change in z with respect to change in x. X is the one that is changing. So the other independent variable y, we treat as a constant. We treat it as our favorite number, whatever that is. We can treat y as our favorite number. Here, this means change in z with respect to change in y. This time, the other independent variable other than y, which is x, we treat as you can treat it as your favorite constant, whatever your favorite number is, your lucky number. And we work the problem that way. These down here are just saying take the partial derivative with respect to x and evaluate it at 5, -5. That means the x is 5 and the y is -5. It's an xy ordered pair. So let's take a look at this problem. Let's start here. And please feel free to ask questions because we're going to use this process throughout our talk today. So we want to differentiate z with respect to x, and when we do that, we treat the other independent variable, which is y, as a constant. You can treat it as the number 0, as the number 5 million, whatever you want to treat it as. So we take a look at our function z. Z is equal to negative 4x cubed plus 6y squared plus 7x times y. We have a product going on in here. We've got the product of 7x times y. So we are going to treat that as f and g. We're going to call 7x, we're going to call that our f, and y we're going to call g. And I don't see our formula sheet up, so let me go grab our formula sheet for Survey of Calculus. So when we differentiate using the product rule, we're still using this product rule right here. So that is f g prime plus g f prime. That top rule here, or that top formula here, has sure gotten a lot of use. So let's go back to the document we were looking at. So let's start. Z equals negative 4x cubed. That first term has only an x in it. The only variable is an x. X is varying. The other variable, y, is constant. So since this term with the x in it is varying because it says change in x, that represents change in x, we need to differentiate this. And we differentiate this as usual because it just has an x in it. And we don't have to be concerned about y at all here. So we just differentiate this just like we normally would. It is we have a negative. Write that down and find the derivative of the rest. The derivative of 4x cubed is 3 comes down, multiplies with the 4 to give us 12. And then we copy down x. We reduce the power by 1. 3 minus 1 is 2. So we've got x squared. Negative 12x squared. So that's not too bad. When you have a term in this context that has only one variable in it, it's really a nice to have. So let's move along to this next term, plus 6y squared. In that term, terms are added. We only have the variable y. Y is a constant. I usually, for all of these problems, look at what's varying, and I immediately write down why the other variable is constant. So y is a constant. It's your favorite number. Let's say 11. If you put an 11 there and square it, you would get 121. And then we need to multiply that by 6. That's 726. That whole term becomes 726. That's a constant term. And that derivative is 0. So you could always use 0 for the number 0 here here. You can always use the number 0 here if you wish. As long as you know that variable is constant. You could put 0 in here. Oh, I've got to move along. 0 in here, square it, and I get 0. 6 times 0 is 0, and the derivative of 0 is 0. So you could treat it like that too. Plus, now this we need to use the product rule for. So we need to look at f and just copy it down. So f is 7x. We can just copy that down. And then the next thing we need to do is find g prime. G is y. Y is a constant. So I can put in 0 for this constant y and look at it as 0. What happens when I differentiate 0? we get 0. And then we need to do the other piece of the product rule, G. So G is Y, we just copy that down. And then we need to find F prime. Well, F is 7x, and x is variant. So we need to take the derivative of this as usual. So the derivative of 7x is 7. And then we just need to clean this up. So in this situation, we can ignore the 0 terms. So we can cross those out. And we're left with the other two, which are negative 12x squared, copy that over, plus, we'll write this as 7y, copy it over to here. That's the partial derivative of z with respect to x. So any questions on the first part of problem number 1? So let's go to the next partial derivative, and you will see the answer is different. So let's look at the partial of z with respect to y. So y is varying here, since this means change, this little partial derivative. We use those rather than the d, dz, dx, or whatever. When we're working in only 2 dimensions, we generally use d's. When we're working in 3 dimensions, we use this partial derivative notation to indicate that something is constant. So let's look at the partial derivative of z with respect to y. This time y is varying and x is a constant. It's your favorite constant. 0 happens to be the easiest one to work with, I think, although 1's not too bad either. So let's start over. And we look at z equals, the first term is negative 4x cubed. And that first term only involves x. In our current state, x is constant. So if we plug in 0 here, 0 cubed is 0 times negative 4 is still 0. So the derivative of that term is 0. Since the whole thing's 0, we can take the derivative of it and get 0. So that term is, the derivative is 0. We move along to this term, plus 6y squared. Y is variant. So we need to take the derivative of this. And we're going to treat y really like we're x, but we're going to use y instead. So we will bring this 2 down, multiply it by 6, get 12. And then write down y right there. And then we want to reduce, since this is simple power rule. This is simple power rule. We did then subtract 1 from the old exponent, so we get 2 minus 1, which is 1. We don't have to write in that 1. And then we are done. Any questions? So we're not looking at, we were looking at, I'm trying to, implicit differentiation. This is not implicit differentiation. So that involved dy dx's. So that's what comes to mind. You want to, when you're studying for the final, you want to kind of understand those little differences and why we do that. In implicit differentiation, we were looking at, we didn't know what y was equal to, and we were looking for a representation of that. So we now need to go along and do the last term plus 7x times y. So first we're going to look at f, it's just 7, and copy that down. Then we need g prime. G is y. G is y, y is varying. So the derivative of y is just like the derivative of x, it is 1. Okay, so it is 1 right there. Plus g. G is y, we just copy down our g, goes right there, times the derivative of f. F, if you see f here, you see 7x. That f only involves x. That's the only variable that it involves, x. So since it's 7 times x and x is constant, we can put in our favorite number, let's say 0 here, get 0 times 7, which is 0. The derivative of 0 is 0. And that's what the reason for the 0 here. So we just want to clean this up. This term, we can ignore the terms with 0 that are 0. So we can cross this one out. We can cross this one out because those terms are 0. And then what do we have left? We have 12y plus 7x times 1, which is just plus 7x right there. Any questions on the partial of z with respect to y? These two down here are just asking us to evaluate. The first one wants us to use the partial of with respect to x. It wants you to use the partial of z. They wrote down the z down here. It should not really be written down there. It should be written up here. But they want us to use the partial of z with respect to x function right here. And then put in 5 for x and -5 for y. So if we do that, we're going to use the partial of z with respect to x function, which is this one. We're going to get -12, copied it down, times x. X is this first coordinate here, so we're plugging in 5 for x and squaring it. So this, I put in 5 squared here. And then we have a plus sign, copied that down. 7, copied that down. And y, what do we want to put in for y? This -5. So I put -5 in parentheses. So I'm sure I would multiply correctly. So if you do this calculation on your calculator, you will get -12 times 25 plus 7 times -5. And that's -335. Any questions on that? The answer is -335. Let's take a look at this one. We're doing the same thing. But we're using a different function. We want to find the partial, the first order partial of z with respect to y now. So we want to find this partial when x is 5 and z is -5 at the same ordered pair, if you will. So what we do is we do the same process, but this time we use the partial of z with respect to y function, which is right here. So let's write down the 12. Y is 5, so 12 times negative 5, since these are participating in multiplication, plus 7, and then our x that is 5. So 7 times 5 is our second term. If we run that calculation, if we put that calculation in our, I want to call it a computer, which it is, into our graphing calculator, you would get negative 25 if you did it correctly, which is the answer. Any questions? Just to give you a little experience working in 3 dimensions. So let's go on. Let's take a look at, sorry for that. Let's take a look at this problem. So another way to represent partial derivatives. We saw one way in problem number 1. In problem number 2, we're seeing another way. They still represent partial derivatives. This is the first ordered partial of the derivative of f with respect to x. Whatever variable is down here is the one that's varying. So x is varying in this case, and then the other one, y, is constant. In this case, when you find f sub y, that means y is varying, and x is the other variable, x is constant. And then this just means after we find these 2 partials, we then want to evaluate them, just like we did before. So it's the same process. It's a little bit different function here that we need to talk about. So let's talk about that function. So our function that we're given is f of x comma y, and that's equal to the square root of x squared plus y squared. So let's take off the square root. A square root sign is really just an exponent. In fact, all root signs like that, square root, cube root, and so forth, are just exponents. So what exponent is it? Let's take the base, or let's take the radicand, what's inside the square root, copy it down, x squared plus y squared, and this square root really represents the exponent of 1/2. If we wanted it to be just x squared up here, we would write it out that way. So it's a good, when we have these kind of root signs, it's 1/, in this case, the understood index in that b. We use this one so much, it's understood to be 2. So this is another way to represent our function. And which rule are we going to use to take the derivative of this? What do you think? What rule are we going to use to take the derivative of this? Which one of our differentiation rules? We can look at this entire function here has a base, x squared plus y squared to the power 1/2. Now note our base is something other than just x. We have a base to a power, and only a base to a power, where the base is something other than just x. This is where we use the extended power rule, where we have 4 steps. So let's look at the first ordered partial with respect to x. The other variable, y, is a constant. So let's do our 4 steps. We bring this power down in front, 1/2. We copy over the base just as it is, x squared plus y squared. We take our old power and subtract 1. 1/2 minus 1 is negative 1/2. And then here's the step we don't want to forget. We need to now multiply by the derivative of this base. And lucky us, our base we have two terms, but we only have x in this first term, and we only have y in this term, which is nice. We don't have to use a product rule or anything like that. So when we're doing this first order partial with respect to x, x varies, y is a constant. So when we take the derivative of this, our base here, it's the x varies, so we differentiate this as usual because it only involves x and it varies. So this would be 2x. And I did cross out the 2's, and I hope you can see them. I try to cross them out in a way where you could still see them. Plus the derivative of y squared. Well, y is a constant. Since y is a constant, it's a number. Y squared is also going to be a number. So the derivative of any number that you know is 0. So I put in plus 0 here to show that. You could put in your favorite constant, 0. 0 squared is still 0. The derivative of 0 is the number 0. So that there are a few different ways you can go about that. So we just want to clean this up. This right here in parentheses is just 2x because the 0 doesn't add a contribution. So I crossed this, I took this 2 divided by this 2, which is 1, and crossed those out. So 2 and this 2. And what are we left with? We are just left with this and this x. So I see that this is negative. I'm going to save that. I first wrote down this x in the numerator. And then since this is a negative 1/2, we can use a property of exponents to take all of this and move this to the denominator. And the only thing that changes is the sign on the exponent. It's going to change to positive 1/2. So we are then going to have x squared plus y squared to the positive 1/2 in the denominator. But positive 1/2, that exponent represents square root. So we're just going to write it as square root of x squared plus y squared. Any questions on the first order partial with respect to x? So let's take a look at the next first ordered partial with respect to y. The other variable x is a constant this time. Going to go through the same process, and you can see the answers are just so ever so slightly different. This one has an x in the numerator, this one has a y in the numerator, and both of them have the same denominator. So let's go through this process, finding this first order partial with respect to y and treating x as a constant. So we're going to start here, 4 steps, bring the 1/2 down in front, the base, copy the base over, x squared plus y squared, take the old power and subtract 1, 1/2 minus 1 is negative 1/2, and then we are going to multiply by the derivative of the base. So we're going to look at this base here, the derivative of the x squared, x is constant. Put in 0, get 0 squared, which is 0. The derivative of 0 is 0 in parentheses because we have 2 terms. Plus the derivative of y squared. Y is varying. So this is just like, this is 2y. 2 comes down, we copy y. We subtract 1 from the power. 2 minus 1 is 1. So we get 2y. That's simple power rule that we used. So 2y right here plus 2y. And that's it. We just need to clean this up. 0 plus 2y is 2y, so we can ignore that 0. And then we can cancel out these 2's in top and bottom. And all we're left with in the numerator is this y. And all we're left with in the denominator, we can put this in the denominator just like we did up here, and we would get this y over the square root of x squared plus y squared. Any questions so far? So let's evaluate. So this is the first order partial with respect to x. We want to evaluate that at this ordered pair, -5, -3. So here's our formula. The first order partial with respect to x. So we see an x in the numerator. We want to put -5 in for that x, and I wrote it down here. In the denominator, we have the square root of x squared plus y squared. So square root x is -5. If you take -5 times -5, you will get 25. Then we see y squared. Y is -3. So we put -3 in here and square it. -3 times -3 is +9. 25 plus 9 is 34. So we get -5 over square root of 34. Any questions on that? Let's evaluate the first order partial with respect to y at 7, -1. So we're going to use this one, which is what we got for the first order partial with respect to y. So we want y, which is -1, to go in the numerator. And then divide it by the square root of x squared. X is 7. 7 squared is 49. Plus y squared. Y is -1. -1 times -1 is +1. Plus 1. Just adding these two numbers together gives us square root of 50 here. For whatever reason, my lab math decided it was going to be like my trig course and require students to rationalize the denominator. Well, not rationalize, I should say, not rationalize, but simplify. And you don't have to rationalize, but you have to simplify. So let's start with square root of 50 and write it over here. 50, what we're looking for is perfect squares. In other words, what could I easily pull out of the square root? So 50 is 25 times 2. So the square root of a product is the product of the square roots. So we want to we can write this as square root of 25 times square root of 2. The square root of 25 is 5. The square root of 2 is not nice, so we leave it inside the square root. So they just wanted us to take the square root of 50 and replace it by 5 square root of 2. And that is the answer they wanted. Now, whether they will accept this or not, I did not test that, so I don't know. Any questions on this problem? So that was number 2. So let me check that off my list. Take a look at number 3. Short and sweet one here. It gives us the opportunity to review some of our differentiation rules. That was a while back that we did that. So let's look. We want to find the two first order partials. The first one with respect to x and the second one with respect to y for this function. So f of x comma y is -5e to the raised to the 9x minus 2y. Now that's nice because each term has only one variable in it, either x or y. So this isn't really too bad to differentiate. This could be a nice non-written work question on the final. I don't know if I'll put it on the final, but that's what runs through my head. So let's take a look. Let's do this one first. That means x is varying, so y is constant. So we just go about this the same way as we're used to taking derivatives, keeping in mind that x is varying and y is constant. -5, copy that down. The derivative of e to a power is e to that, here's the power, it's f of x in this case, so the derivative of e to a power is e to the power times the derivative of f, that's just the power, the derivative of the power. So I like to say it's the derivative of e to a power is e to the power times the derivative of the power. So you will still have a formula sheet with your comprehensive final. So the derivative of e to this power is e to the power times the derivative. We go upstairs and take the derivative of the power. So we just copy down e to the power. E raised to the 9x minus 2y right here. Then we go up and take the derivative of the power, keeping in mind that x is varying and y is constant. Let's differentiate term by term. The derivative of 9x, x is varying, so that's business as usual. Since we only have x here, the derivative of 9x is just 9. Minus the derivative of 2y, well, that term has just y in it, and y is our favorite constant, say 0. 0 times 2 is 0. The derivative of 0 is 0, minus 0, it doesn't add any additional contribution. So this is all we get right here. Cleaning that up, -5 times 9 is -45, and then we have just this left, e to the 9x minus 2y. I just copied that over, and that is the answer. Any questions on the first order partial with respect to x? Let's look at 3 and part B. So now we want to find the first ordered partial with respect to what? Y? This time, the other variable x is constant. So we start by writing down -5, the number multiplier. We write it down and find the derivative of the rest. That's what we've been doing all along with derivatives. Write down the number multiplier and find the derivative of the rest. And the rest is this. And the derivative of e to a power is e to that power. So I just copied that down, e to the 9x minus 2y times the derivative of the power. Now this time y is varying, so x is constant. This first term has an x in it. If you put in your favorite number, could be 1. 1 times 9 is 9. The derivative of 9 is 0. I didn't even write that in. Minus 2 times the derivative of y. And the derivative of y is just like the derivative of x. It's just 1. So minus 2 times 1 is just minus 2. So I wrote that down. Cleaning this up, negative times negative is positive. 5 times 2 is 10. And then we need to copy this down, just as is. E to the 9x minus 2y. And that's the answer. I just put it up here, so I didn't have another long arrow. Any questions on number 3? So let's take a look at, number 5. So I'm just checking off my list here. Let's look at number 5. I want to make sure I'm practicing derivative rules as well. Different ones. 5. Find the first order partial with respect to x and also with respect to y for the function f of x comma y equals y times ln 3x plus 8y. Now there's an understood multiplication sign here, so we really are going to have to use the product rule. And let's take a look. So there's multiplication here. We've got a variable here, and we've got a variable in here. So let's make just the y f and the ln of all of this g. So let's find the first ordered partial of f with respect to x. That means the other variable y is constant. So we are going to use the product rules, which says that we just copy down f, and f is y, so just copy it down, times g prime. So g prime is ln of 3x plus 8y. When we differentiate a natural logarithm of an argument here, it is the derivative of the argument over the argument. So the derivative of this argument here would be, we differentiate term by term, and keeping in mind the x varies and the y is constant. So our first term involves just x, the variable x. So x is varying, so we need to differentiate this term. So the derivative of 3x is just 3 times the derivative of x, which is 1. 3 times 1 is 3. Plus, the second term is 8y, and we can, y is constant. So we can just put in our favorite number there, whatever it is, say 0. 0 times 8 is 0. The derivative of 0 is 0, so we don't have to put in plus 0. It's not going to change. It's still going to be 3. So that was the derivative of the argument over the argument. The argument is 3x plus 8y. So that's the first part of the product rule. Plus g. We just copy down all of g. ln 3x plus 8y, copy it down, times f prime, the derivative of f. So here's f, it's y. Y is constant. So we put in our favorite number, say 0. We need to find the derivative of 0, which is 0. And that's 0 right there. So this whole term is got 0 times this is 0. So we're just looking at this first term right here now. So we get 3 times y, which is 3y, over, just copy this down, 3x plus 8y. And that's the answer. So this is our answer. Just to be clear. So any questions on the first order partial with respect to x. Let's now look at the first ordered partial of f with respect to y. Y varies. The other variable x is now, we need to treat it as a constant. So again, we're going to use the product rule. So the first step is copying over just f, which is y. Second step is to find the derivative of g. So the derivative of ln of an argument is the derivative of the argument over the argument. The derivative of the argument, let's look at that. So let's differentiate 3x. X is a constant. Put in 0 times 3 gets 0. The derivative of 0 is 0. And then plus the derivative of 8y. So that's 8. 8 times the derivative of y. Y varies. So it's like the derivative of x. It is 1. So we get 8 times 1, which is 8. Any questions on that? And then it's over the argument. 3x plus 8y, we just copied that over, 3x plus 8y. So that's the first term. Plus the second term, g, just copied over, ln of 3x plus 8y. Times the derivative of f. Here's f, it's y. Y is varying here, so we have to take the derivative of y, and that is 1. It's just like the derivative of x. We're just using a different variable. So that's 1. So this is times 1. And if we clean this up, so this is 5. I went down here just a bit, got 5 there to clean it up. So the first ordered partial with respect to y is, this is just 0 plus 8, which is 8 times y. So it's 8y in the numerator, at least in the first term of it's the numerator in the first term. So we get 8y over 3x plus 8y copied down. Plus the ln of this argument times 1. That's the multiplicative identity. So this is ln of 3x plus 8y. So plus ln 3x plus 8y. And that is the answer that MyLab Math got. Any questions on problem number 5? So I wrote down problem number 9. So let me see here. So this is I try to keep this short and sweet. There are 9 questions in this particular assignment. I wanted to give you more time to work on that final exam review assignment. Let's look at number 9 here. So number 9, we have find the first ordered partial with respect to x, with respect to y, and with respect to this Greek letter lambda. This comes up in Lagrange multipliers, which you may see if you go on in math. So we have 3 variables here that could vary, and we're going to deal with that. So what does this mean? We want to find the first ordered partial with respect to. This means that the other 2 variables are constant. So in this case, up here, the variable y and the variable lambda are constants. Those are constants. So I'll just write those out there. Both of those are constants. So I'll call that our constant column. Constant, so I've got to so these guys in this column are constants. Your favorite constant, favorite number. So let me make this as big as I can so we can all see it better. So let's see what I did up here. Just taking a look. I copied it over here so that it would be a bit bigger for you all to see. That's what it looks like I did. So I want to focus on this. Let's focus on this. That's what we want to focus on. So this is a little tricky here. And you see that I've got this term right here, ignoring the, well, not including this negative sign. So I've got this lambda times this. We've got this lambda times this. So that we're going to have to use the product rule on. So I labeled just lambda, not the negative. F doesn't include the negative. I labeled just lambda with F. And then I labeled this other factor with G. So let's find the first ordered partial with respect to X. The first term consists of just X. X is varying. So we take the derivative as usual. That would be just 2X. So the first ordered partial with X equals 2X to start, and then plus the derivative of Y squared. That term only involves Y. Y is a constant. So the derivative of this would be 0. You could put 0 in for Y, your favorite number. 0 squared is 0. The derivative of 0 is 0. So plus 0. And then this minus sign. This minus sign is right here. And then we are going to put a big set of parentheses around what we get, because we're going to use the product rule, and it's minus everything you get from the product rule. So let's do that. So the product rule says that we want to take our F. Our F is just lambda. So I wrote that, copied that down. Times G prime. This is G. And luckily, every term is constant or involves one variable only. So let's differentiate term by term. So the derivative of 8x, x is varying. So it's business as usual, is just 8. So wrote down the 8 plus sign. The derivative of 3y. Y is in our constant column over here. So we put in our favorite number for a constant, say 0. 0 times 3 is 0. Derivative of 0 is 0. Put that right there. And then minus the derivative of 15 is 0. I just wrote it in as plus 0. It doesn't matter if you put minus 0 or plus 0. So that's what I got for the FG prime part of the product rule. So then we need to add to that plus sign. G is all of this. So I copied down all of that. times the derivative of f. F is just lambda. It doesn't include the minus sign. Lambda is over here. It's one of our constants. And so since it's a constant, we can just put in 0 for it. And we wanted to take its derivative. The derivative of 0 is 0. That's where that came from. So we just need to clean all of this up. It's not as bad as it looks because all of this is gone. 0 times all of this is still 0. So all of that's gone. So we're just looking at here inside, we just have lambda times 8, which is 8 lambda. So all we get is 2x plus 0, doesn't add anything, minus, so we get 2x minus 8 times lambda. That's it. So even though it looked a bit horrendous, I suppose, or, complicated, it's really not. But the main thing is, I would suggest you don't include this minus sign. You leave it the way I did it. It gets kind of complicated if you do. You got one more minus sign going around a lot more than you would like. I would encourage you not to treat it like I did. So let's take a look at the next one. This time, what are our constants? So this time, y is varying, so the other two are constant. That means x is a constant and lambda is a constant. So let's look at this problem and we're still looking at this, but we are now keeping in mind that y varies and these other two, x and lambda, are constant. So we'll start here. The first term just has an x in it. X is a constant, so we can put in our favorite constant 0, say 0 squared is 0. The derivative of 0 is 0. So I didn't write that one in. I maybe should have, but I didn't write it in. Don't need to write it in. Plus, y is varying. So we want to differentiate this as usual. This is just like x squared, which would be 2x. This is 2y. Just copied it down. And then minus, made these big set of parentheses. We now need to use the product rule. F is lambda. Wrote down lambda. Times g prime. So here's g. Let's find g prime. The first term involves x only. X is constant. So we know what that's going to be. It's going to be, that whole term is going to be 0 because it only involves one variable, that whole term, and that variable is constant. So that derivative is 0. Plus the derivative of 3y. Now y is varying. So we want to take the derivative here. This is just like the derivative of 3x, but it's with y. That derivative would be just 3. Plus the derivative of this constant, negative 15, which is 0. So plus 0. So that's the first half of the product rule. We have a plus sign in between. Now we want g. G is all of this copied over right here. Times f prime. F is lambda, just lambda. Lambda is constant. So the derivative of just this constant is 0 right here. So that was times 0. So all of this is gone. So 0 times this is is just 0. And what else can we clean up? Let's go back to the beginning here. F, this first order partial with respect to y. Definitely we want this 2y. Minus sign definitely. And all we get, that's all gone. All we get out of this in here is a 3 times lambda. So we get minus 3 times lambda. And that is what the first ordered partial of f with respect to y is. Any questions about that partial? Let's take a look at the first ordered partial with respect to lambda. This time, the other two variables, x and y, are varying. Whoops, I was thinking about the one that was varying. So let me get that. And this is lambda is varying, so x and y are the ones that are constant. So we're going to play the same game. It's going to be a little bit different. You can see there are 3 terms. But why is it 3 terms instead of 2 like we've been getting? So let's start. So our variable that is varying is lambda. That means that x is a constant. And this term just involves x. So it's just the only variable that this term involves is x. So we put in our favorite number 0, say 0 squared is 0. The derivative of 0 is 0. Same thing's going to happen with the y squared term. Y is constant, so put in 0. 0 squared is 0. Derivative of 0 is 0. Minus. Now we're going to use the product rule. So we want f. And we're going to put it in parentheses like we've been doing. So f is lambda. And then we want to find g prime. So all of this is g. This term involves an x and just an x, which we know is constant, so that a whole term is constant, and that means that derivative is 0. This term involves y. Y is a constant. So constant times a constant, 3 is still a constant. The derivative is 0. This term, the derivative of negative 15, is 0. So we get that right there. Lambda times all of this. We'll look at that in a moment. And now we need to do the other part of the product rule, which is g. Copy all of this down. Times the derivative of f. F is lambda, and it's only lambda. And lambda varies. The derivative of lambda is like the derivative of x or the derivative of y. It is 1. So times 1. So let's see what we get. And we get these are gone. And then minus all of this. So I want to put this minus sign out in front from here, this minus sign. And then we're going to go inside here. All of this is gone. This first term here, if you will, is gone inside the parentheses. All of this is gone. And what do we have left? So I see how I did this. So we have 8x plus 3y minus 15 times 1. That's just this right here. So we really just need to focus on this. because one's a multiplicative identity. So this negative sign, right here, I distributed through the negative sign. So this gave this negative right here, negative 8x here. This negative right here, negative 3y here. This negative of a negative 15, positive 15. And that is the answer. Any questions on this particular problem? So that's what I wanted to cover today. I think I did 4 or 5 problems for you in a 9-question assignment. I will make sure I put my notes in MyLab Math for you like I have been doing. And I want to come back up to you all now. It was a pleasure to have all of you in class. I do need to get the attendance. I enjoy teaching Survey of Calculus so much. I've been doing it for a long time, and you all have been a pleasure to have. And I will get to grading your test today. Finally, I just have so much come up at this time of the semester that I didn't even know was going to come up. And so it's one of those things, and I want you all to have your know how you did on test 3. Also, I am dropping the lowest of the first 3 test scores. Keep that in mind. I cannot drop the comprehensive final. We are required by the Department of Math to have the final count for at least 20% of the course grade. So I want to make you aware of all of that. And let's see, what else do I need to do? I wish you the best. If I can help you in any way, let me know. If you need advice, if you need a recommendation, whatever, let me know. And take care. And I hope you all find a good career path that you love doing and you feel like it's part of you. I was talking to a student that I have that works in a nursing home, and she tests patients for COVID, and she told me that's where she's supposed to be, and she knew it. I had another student recently I wrote a recommendation for. I asked him, he wanted me to write a recommendation to West Point, and I asked him, do you know with every fiber of your being that this is what you want to do? And he said, yes. So I hope that you all find and feel like that you find and you are living what you are and what you are meant to do. And that's my wish for all of you. So take care. I wish you all the best, and reach out to me if you have any questions, and I will let you know just as soon as your test 3s are graded and that I have dropped your lowest test score. Bye for now. I hope to see you somewhere, maybe in person one day. Take care.
Thank you so much.
You're welcome.
Bye.
Bye. Bye, Miguel.